Okay, thanks. Our next speaker is from Huawei, Linda Dunbar. And Linda is a distinguished engineer and technical lead in Huawei's fixed network business line, where she has been responsible for leading the SDN NFV architecture development for large-scale cloud data centers and network services. And she's currently chairing multiple committees, the ONF L4 to L7 group, leading 9-vendor NFV ONF service graph forwarding proof of concept project. And she's actively contributing to a number of IETF and organizations, Trill, Inner Area, and the OP area. So she serves as an IETF Ops Area Directorate and is secretary to the TSV area. And in the past, she's chaired multiple committees. And she's worked for Huawei, Cisco, Nortel, and Fujitsu over a career spanning around 20 years. So welcome, Linda, and thank you. And we'll bring up your presentation. Uh-oh. That is you, right? Where is the... There we go. Excellent. Thank you.
Thank you very much for the introduction. Good morning, everyone. Thank you for being here this early. I know it's not easy to be here. So my topic today is virtual network security functions as a service. Please feel free to ask questions and make sure you get away what you need from this presentation. So I'll talk first to start with the challenges of network security function as a service. So the cloud, right? A few years ago in IETF, when the cloud was first brought up, lots of people questioning, what is cloud? And there's so many things about cloud. And today, cloud is reality. And there are many, many small and medium enterprises, they actually use security function in the cloud. In the cloud, meaning a third-party provided security functions. And many small enterprises, and they don't have the expertise to manage the security devices on their premises. So what they do is to lease the services from a third party, and they use their portal to configure the security policies. So, but the question is, when operators, network service providers, have many security functions from different vendors, how do they manage them? How do they provide the needed services to their client, to either enterprise clients or their consumer clients? And so today my talk is primarily focusing the mechanism, the architecture to allow service providers to integrate security functions from different vendors. So when we talk about virtualized security functions, so what it is you may have a big, large box and shared by many users or clients. And by virtualizing it, you allow each client to at least feel that they own a piece of it, that's theirs. So for like mobile operators and then mobile users, they may have a virtual web filter or virtual WAN optimization. When they move from one location to another location, and this particular virtual WAN optimization or the virtual web filtering can move with them, and they feel they own that, and they can configure it the way they want and set up the policy they want. So here is a use case of NFV showing that for virtual CPE, once you have a virtual CPE, is a piece of CPE running on x86, the functionality is limited, and then to make it be able to perform all the needed functions, you need to add more security functions. And those security functions can be executed or implemented in the virtual format. So the desired operation from operator's point of view would be like they can associate a customer, a client, to a virtual network security functions. And they can cancel the subscription. And they can move this virtual security function with the client as the client moves from A to B, different locations. And they will allow the client to be able to view it and be monitor the execution of those security functions. So let's look at a data center example. Today, many people, we have heard a lot about discussion on data center. Like Amazon's EC2, right? You can go to Amazon to lease many virtual machines, and you can even create your own network. You can lease 100 virtual machines and maybe divide them into 10 different virtual networks. And you, as a client, can determine how the policy you want among different virtual networks. Maybe virtual network 1 can talk to 2, and 2 can talk to 3, but 1 cannot talk to 3. So from the client perspective, that's what the policy they would like to have. So conceptually, you create this virtual network, and you want to create a virtual firewall among your virtual networks, right? But that's what desired form today. But the reality is, I just use firewall as an example, not necessarily other security functions will be included as well. Today's firewall configuration, most of them are, actually virtually all of them, are port and link based, right? So you look at address and you look at which access port you come in, and you configure allow or deny, right? So it's very detailed. But for the client whose network is virtual, they may not even know where their virtual machine actually resides. They may have the virtual address, but how the virtual machine or virtual network mapped to the real network is not known to the client. So make it very difficult for the client to manage those kind of virtual security functions. From client's perspective, their desired operation will be, hey, I have yellow and green zone, and this is what I want, right? The yellow can talk to green, but green cannot talk to yellow. So maybe they can monitor the TCP port. The traffic can only come from yellow to green, not other way around. So this is the preferred way. It's more logical, more conceptual policies. So to enable those kind of operation, a desired result of the virtual network security functions, here's several things we need to take into consideration. First of all, virtual security functions. Security function by itself, vendor A is dramatically different than vendor B, right? So you may talk about firewall. What company A's firewall is very different from company B's firewall. And how they get started, some basic configuration, they're all different. And in this non-vendor proof of concept for service training, we learned that every company actually had their own management system to manage their own functions. So their management system need to tell the operator, okay, what kind of service function they are, where they are located, and also a set of attributes or profile that allow the third party to modify. The attributes can be exact policy, like I allow the third party to modify my port, TCP port, based on TCP port to determine the policy. Or it could be more sophisticated, like for this kind of security function, I only give a URL. I provide your portal, allow you to modify it. So there's a registration needed for that interface. In NFV, I think it's through the interface mapping to the NFV architecture is OR-VNFM. And And then for the operator, when they provide service to the client need is very abstract model. Like, I want my green network talk to my yellow network. I don't really care how do you enforce that, right? So that's the abstract level policy. We call that service layer security policy. And then from the security, the service layer security policy, the operator's OSS has to translate that into individual functions policy. Like function A can only enforce layer 3 based policy. Function B can enforce like HTTP layers function. So for a client, for one particular policy, you may need multiple service functions to achieve the desired result. Here, just give you a little bit detail about the service layer policy, which to the client, to the end customers, and then the function layer policy to individual service functions. So we believe that for the service layer policy should be expressed by like RESTCOM, can be expressed by this role-based access control. There are quite a few different ways to describe the service layer policy. And for the function layer security policy, and in IETF, we're using this like I2RS or NetConf to be able to express very exact the policy to the individual functions. So what kind of clients would be for this kind of interface? And we have heard a lot about SDN, have applications, trigger network, and we found that in the reality that the application is not about application on your cell phone, right? It's not an end user. It's actually is the application gateway. Give you an example. You may have, everybody have used video conference, right? So say in my company, we have many different zones. And like in normal time, I cannot talk to a person in red zone. I'm in the white zone. And, but when I need to talk to him through the video conference, initiate the video conference request, the video conference manager can assign like a particular port for us, like for example, port 5000. And then during my call, the video conference manager can tell the network, please open port 5001. And then when I finish the talk, they disable that port. So with that, you can ensure the secure communication. Without this interface, in the past, today you're basically saying, okay, all the video conference is from 5,000 to 6,000, and all the ports have to be enabled. With that, you can create lots of security holes. People can hack into your system much easier. So with this kind of interface, we allow very tight control of communication among peers, among the clients. So that's one type of the client to this service layer interface. And there could be also the OSS, the Operator's Management System, have interface to the security functions. And it could also be the function themselves. Like, for example, in your network, you may have a security scrubbing center, but your capacity is limited. You cannot take all the traffic to the security scrubbing center. So you may have a threat monitoring service function and monitoring different kinds of threat. When you detect there's a threat with packet size, say 47, cause potential threat, you can initiate a request to the other security function saying, now for all the traffic, packet size equal to 47, please steer it to the scrubbing center. So the client could be also some type of security functions. Here is like at the service layer, right? When operators OSS present security policy to their clients, it is very abstract, kind of easy to understand, intent-based. For example, Here are some examples like enable the parental control, allow the internet from what time to what time, allow person to watch YouTube video from maybe after 6 p.m. So those are very abstract description. And at this layer, we recommend using some kind of rule-based access control or attribute. There's quite a different models to describe that. And here, I only give you an example of this rule-based access control to describe those service layer security policies. This picture is a little bit too complicated, and if you have questions, welcome to ask me afterwards. For the functional layer security policies, we currently take what is, like in OpenStack, there's a firewall as a service. We just take what they have today. Basically, you describe the different type of policies. You have objects, right? Object can be based on segment of the network, can be based on packet, the bits or field in the packet, or can be based on application subscriber ID, can be based on the time of the day, and then the actions. Besides the normal actions we have for pass and fail, or pass or drop, you could have actions of steer the traffic to another function. So this is at the function layer. This is supported by individual functions. And this expression can be easily represented by like a Young model, the netconf model. And the third subject, I'll talk about how to register the security function capability. So what it is basically the user need to register what the function they have. And among security functions, there will be some common attributes, which is like common to all virtual network functions. You will indicate your vendor, your type, whether you support the service chain header or not, whether you can differentiate different virtual network by VLAN or PLS tag. So basic contributions, configurations. And you can also indicate, like for this particular security functions, what kind of policy you support to change. Could be simple as a profile, right? I support profile 1, 2, 3. And then in a different definition, you define what profile 1 is, what kind of attributes it is.
5 minutes.
And for security function, here we define security functions as, like, there are many types of security functions, right? When you talk about security, you have security for the end nodes. You have security for the link, like TLS is one example, IPsec is another example. And here we talk about the flow-based security, meaning the security applied to traffic, okay? So for the security applied to traffic, and today's routers support great amount of them, like for stateless, layer 2, layer 3 header security access control, supported by many commercial routers today. But if you want to do one step further, like if you want to support a stateful firewall, if you want to support a TCP port-based security, or if you want to support HTTP-based header, so that will be provided. That's today provided traditionally by some middle boxes. So for the security function, when they register the operator's management system, they have to indicate what level of security they support and what attributes they support, and whether they support the IETF PCP or the TRAM. Okay. So those are the type of registration the vendor has to register. With that registration, operator can build up a database, the catalog of security functions. So when the user's requests come, they can decompose that and then use the needed service functions to achieve the policy. Another thing is for each function, you may have many instances. So the vendor also need to register. I have 10 instances for function A, another 20 instances for function B. So here it is for the the service layer abstract security policy, there will be a module to terminate that security policy and then translate into the functional attributes. And it is possible for one policy being supported by maybe 2 or 3 security functions. Last, since my time is off, we started this work in IETF, and in last IETF, we had a BOF. It's called I2NSF, Interface to Network Security Functions. And here's a mailing list and drafted charter. So if you don't go to IETF, you can go to those links and look what is going on and express your opinion. Thank you very much.
We have a couple minutes for a couple questions, if there's any questions from the audience. I think Linda's presentation showed that there's a lot of complexity and issues behind the scenes, but the way it's described to the policy control management folks and so forth, they're getting very high-level directives to actually control the policy. So I can imagine that the work that the IETF is doing and the other standards groups to move this toward a standard model with all this flexibility has got to be quite a challenge. So please feel free to talk to Linda at the break and later on today. I'm sure there's a lot of information that she can convey to you that would be very useful. Thank you.
Thank you.